They surround us, invisible to the naked eye, ancient, mysterious, and closer than we ever imagined. These are the Milky Way's closest neighbors, galaxies that have been quietly orbiting, colliding, and even being absorbed into our own. Some are merging with us. Others hold clues to the early universe, and a few are so faint they're on the edge of being torn apart. What exactly is hiding next door to the Milky Way? And what does it mean for us? Hello and welcome. I'm John, coming to you from Infinite Universe NTH. Today we're taking a journey through our cosmic neighborhood, because the Milky Way isn't alone, and the galaxies around us tell an incredible story about gravity, time, and the fate of the universe itself. We often think of the Milky Way as a lone island in space, but in truth, it's part of a vast structure called the Local Group, a collection of over 50 galaxies bound together by gravity. These galaxies range from huge spirals, like Andromeda, to tiny dwarf galaxies, like Ursa Minor. And the distances between them? While enormous, they're surprisingly close, in cosmic terms. Some orbit us, some are drifting away, and others are moving toward a future collision. Together, they weave the gravitational web of our little corner of the cosmos. Before we meet the 6 closest galaxies, let's take a step back to compare them all by size, including our own. At the top of the list is Andromeda, a massive spiral galaxy, estimated to be over 220,000 light-years in diameter, with more than 1 trillion stars. Next comes the Milky Way, slightly smaller, around 105,000 to 120,000 light-years across, containing an estimated 200 to 400 billion stars. Then there's the Large Magellanic Cloud, about 14,000 light-years wide, irregular in shape, but rich in gas and dust. The Small Magellanic Cloud follows, roughly 7,000 light-years across, much smaller, but still active in star formation. Now we reach the dwarf galaxies. The Sagittarius dwarf galaxy, approximately 10,000 light-years wide, and home to around 100 million stars. And the Canis major dwarf galaxy, slightly smaller, at roughly 7,000 light-years across, but possibly containing up to 1 billion stars. And finally, Ursa Minor, among the faintest and smallest, spanning only a few thousand light-years and hosting just a few 100 million stars. Its structure is fragile, barely holding together under the pull of the Milky Way. In this scale, we see the vast range of galaxy sizes, from the magnificent to the nearly invisible, and how even the smallest can have an outsized role in our cosmic story. The closest known galaxy to the Milky Way is the Canis major dwarf galaxy, only about 25,000 light-years from Earth. It's so close, in fact, that it lies behind the plane of our own galaxy and was only discovered in 2003. It's currently being torn apart by our galaxy's gravity. Stars from Canis Major are being absorbed into the Milky Way's halo, contributing to the very structure we call home. Some astronomers believe this ongoing merger may be one reason for the thick disk of stars seen in our galaxy today, and recent simulations suggest that the Milky Way may have consumed over a dozen such dwarf galaxies in its past, with Canis Major being the latest known example. The Sagittarius dwarf galaxy is another close neighbor, about 70,000 light-years away. Like Canis Major, It's also in the process of being pulled apart by the Milky Way's gravity. Its stars have formed long tidal streams that loop around our galaxy, fossil trails of a cosmic collision. These streams help astronomers trace the Milky Way's gravitational field, like mapping invisible ripples in space. In 2025, new models using data from the Gaia mission have revealed even more intricate patterns in these streams, helping us refine the shape of the Milky Way's mysterious dark matter halo. It's a powerful reminder that galaxies evolve through interaction and gradual integration. Next, we look to the Large Magellanic Cloud, about 163,000 light-years away. It's one of the few galaxies visible to the naked eye from Earth, especially from the southern hemisphere. Unlike dwarf spheroidal galaxies, the Large Magellanic Cloud is irregular in shape and rich in gas and star formation. It contains the Tarantula Nebula, the most active star-forming region in our local group. Recent research from 2024 and 2025 suggests the Large Magellanic Cloud has a significant dark matter halo, giving it more gravitational influence than we once thought. It may even be distorting the Milky Way's motion, pulling on us subtly but meaningfully. Some scientists now theorize that the Large Magellanic Cloud could be on its first infall into the Milky Way, a relatively recent arrival, making its influence all the more dynamic and potentially disruptive. Close to the Large Magellanic Cloud lies the Small Magellanic Cloud, about 200,000 light-years away. It's also visible from Earth and has a more spherical shape. The SMC interacts gravitationally with both the Large Magellanic Cloud and the Milky Way, creating long streams of gas, known as the Magellanic Bridge and the Magellanic Stream. These features are helping astronomers map the complex dance of intergalactic interactions. New ultraviolet observations suggest these streams contain pristine gas, unprocessed since the early universe, giving us rare clues to the story of cosmic chemical evolution. Ursa Minor is a classic example of a faint dwarf spheroidal galaxy. It lies about 200,000 light-years away and is difficult to observe due to its low brightness. But despite its humble appearance, Ursa Minor holds valuable clues about galaxy formation in the early universe. Its stars are old, metal-poor, and show little recent activity, a living fossil of cosmic history. Recent high-resolution stellar mapping has revealed that its core is more stable than expected, possibly due to a compact dark matter core, challenging older models of how dwarf galaxies disrupt and dissolve under gravitational stress. Ursa Minor may be small, but it's teaching us big lessons about the dark side of the universe. Last but not least, we can't forget the Andromeda Galaxy. At 2.5 million light-years away, it's not the closest, but it may be the most important. Andromeda is on a collision course with the Milky Way. In 4 to 5 billion years, the two galaxies will merge, forming a new elliptical galaxy nicknamed Milkomeda. Andromeda helps us understand spiral galaxy structure, star dynamics, and the fate of galaxy groups. In 2025, new observations from the James Webb Space Telescope have refined our knowledge of Andromeda's halo and satellite systems, revealing that it, too, has absorbed numerous smaller galaxies over time, just like the Milky Way. following a shared evolutionary path in a universe where mergers shape the future. In astronomy, close is relative. For galaxies, a few 100,000 light-years is practically next door. But being close doesn't just mean proximity. It also means gravitational interaction. Galaxies like the Magellanic Clouds are not just near. They actively shape the Milky Way's behavior. And galaxies like Canis Major and Sagittarius are physically merging with us, blending their stars into ours. These interactions change everything, from the motion of stars to the shape of spiral arms to the very way we define our cosmic identity. In the past 2 decades, astronomers have discovered dozens of new dwarf galaxies around the Milky Way. Most are extremely faint, composed of just a few million stars, hidden in the glare of the galactic disk. But this is just the beginning. With future telescopes like the Vera C. Rubin Observatory coming online, scientists expect to find even more. Some may be so small, they challenge the very definition of what a galaxy is. The sky is still full of secrets, and the more we look, the more neighbors we seem to find. The sky is still full of secrets, and the more we look, the more neighbors we seem to find. But to truly understand those neighbors, we have to understand ourselves first. The Milky Way is not just a member of the local group. It's one of its 2 giants, along with Andromeda. Together, they anchor dozens of smaller galaxies, shaping their motions and evolution. Understanding our place in this group helps astronomers model the broader structure of the universe, and it may help explain how galaxy clusters form, collide, and evolve over cosmic time. In many ways, we are a gravitational lighthouse for others, but also a product of countless past mergers. And those past mergers, they're more than cosmic footnotes. They're the building blocks of who we are. The galaxies closest to us aren't just astronomical curiosities. They're part of our history and our future. The streams of stars from merging dwarfs helped build the Milky Way's halo. The gravitational pull of the large Magellanic Cloud is tugging on our galaxy's disk. And the future collision with Andromeda will redefine what our galaxy becomes. To understand where we're going, we have to understand who and what surrounds us. When we talk about nearby galaxies, we tend to focus on what we can see: stars, dust, glowing gas. But most of the mass in and around these galaxies is invisible. Dark matter is the silent partner in all of this. It doesn't shine, doesn't reflect light, but exerts gravitational pull. It's the scaffolding upon which galaxies form. The Milky Way's closest galaxies offer an opportunity to study dark matter on small scales. Some, like the ultra-faint dwarfs, appear to be almost entirely dark matter, mere whispers of light orbiting vast halos of gravity. Understanding these hidden components may help us solve one of the biggest mysteries in cosmology. Once upon a time, we thought a galaxy had to be big, bright, and full of stars. But now, we know better. Some galaxies are so faint they can barely be detected. Some have no gas. Some, possibly, no stars. This raises a profound question. What actually defines a galaxy? Is it a threshold of mass, a bound system of stars, or a dark matter halo with structure? The closest galaxies to the Milky Way are helping us rethink these definitions. They challenge our labels. and stretch the boundaries of what counts as a galaxy. Each of these galaxies, whether faint or massive, is more than a number in a catalog. They are messages from the edges, clues to cosmic history. They carry the imprint of past collisions, the quiet rhythm of orbits, and the fingerprints of time. And they remind us that even in the darkness between stars, stories are still being told. The Milky Way isn't alone, not just in space, but in experience. We exist in a galaxy that has grown through connection, and perhaps so have we. This is John, signing off from Infinite Universe NTH. See you in the next frontier.